Hello, everyone, and welcome to today's SANS webcast, MITRE ATT&CK for ICS Live Demonstration, sponsored by Dragos. My name is Carol Auth of SANS. Today's featured speakers are Robert M. Lee, CEO at Dragos, and Austin Scott, Dragos ICS Penetration Testing Principal. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Robert.
Thank you so much, and welcome everyone. Thanks for joining us today. There was some difficulties with the platform when we recorded and did the live demonstration. We had over 1,900 people on, which is a nice SANS record. So thank you all for your interest and paying attention to it. So because of that, we went ahead and we're doing the re-record right now. And so we're going to continue on as if we were giving it yesterday. That way you have the full material and can see everything clearly. So today's discussion really is around MITRE ATT&CK from both the offensive and the defense perspective. It is a framework, and we'll talk about this as we go through, but a framework to talk about detection and to think about how you do detection across your organizations. You can use it in a lot of different ways, and thinking about emulating threats as well for red team purposes as an example. But really the whole point today is to tell you about the framework, show you the offensive side where Austin and the team put together an ICS range that we have at our Dragos headquarters. And he went through and actually emulated one of the adversary groups that we track and showing you how this might look on an industrial side of the house, and then showing you the defense view in the Dragos platform of what an analyst could expect to see, which whether or not you're a Dragos user, hopefully will be really useful on understanding kind of the defensive view of it. And then I'll end the discussion kind of more of the promotional side of what Dragos does for our customers, just a little bit of education about us. So hopefully together, it'll be something that's useful, not only from our company perspective and talking to you, but also just general education and information for you about a really cool framework that hopefully can help you with your ICS security. So with that, next slide. So I'll start off with just a couple quick slides. The real focus of the show, of course, is Austin and his work. But you know, I'm also the course author and instructor over for the SANS ICS 515 class, which is around active defense or things like network security monitoring and incident response. And to kind of set the stage for the discussion, I want to talk about these industrial attacks. You know, a lot of folks typically think about the ICS malware families we've heard over the years, right? Crash Override and Trisis and Black Energy 2 and Havocs and so forth. But a lot of the ICS attacks we see and a lot of the activity we see from adversaries just isn't around ICS malware. While it's important to understand and be able to detect and respond to those ICS malware cases, really I want you to focus on the adversary themselves. And we think about adversary activity as it relates to your industrial environment. One of the models that we use, a model that Mike Asante and I wrote years ago, was titled the ICS cyber kill chain. And we generally think about stage 1 and stage 2 attacks. So stage 1, or the intrusion, that's your Lockheed Martin kind of cyber kill chain view, if you will, and a very effective model just to think about the steps an adversary takes. But the extension of that into ICS is that stage 2 component. So what we really care about is when we start seeing actions in stage 1 that relate to things that an ICS adversary would be interested in. So maybe the act in stage 1 would be getting VPN connectivity into the industrial operations, or maybe it'd be stealing user accounts and things specific to the industrial side of the house, or compromising information that would be useful to starting to develop an attack, like stealing engineering drawings or data historian information off of an IT data historian. Those things that would position an adversary for stage 2. And really what we care about in stage 2 is those things that could impact our physical process, impair our response functions. If it's not disruptive, maybe even stealing intellectual property and things out of the industrial environment. But to really be a stage 2 attack, we are talking about something disruptive or destructive in that industrial environment. And the adversary is ultimately going to go through a number of steps. One of those, when we think about develop, isn't just about malware. You can also be developing knowledge on the industrial assets. When we think back to the cyber attack that took place in Ukraine 2015 against their distribution system, the malware in that story, Black Energy 3, got a lot of discussion. that was really on the IT side of the house. That was the access tool. That was the stage 1 capability. When it came time to the stage 2 attack, they didn't leverage malware for the attack. They leveraged malware to delete systems to amplify the attack. But the attack itself was really the adversary developing knowledge about how to use the distribution management system, testing out that they knew how to do it correctly, delivering really themselves back in the environment using VPNs and remote desktop assistant, and then modifying the distribution management system in a way that wasn't normal operations, and executing their attack by opening up circuit breakers across those distribution substations. So again, don't be too focused on malware and exploits and vulnerabilities, though those things are important and we want to detect them. A lot of what we care about in the ICS side of the house is understanding the behavior of the adversary, understanding how they're accomplishing their objectives, because there's a lot of native functionality in our industrial equipment that you don't need exploits or malware to do destructive or disruptive things. It can help, it can amplify when you be ready for it, but a lot of the focus is how could they use what's here already, or quote unquote living on the land? How can they take advantage of that from an ICS specific capacity? So next slide, please. So when we think about detection and we think about how we're going to approach this problem, there's a lot of different terms and terminology you've heard in your careers. And it can be daunting, especially with all the marketing words that go around it of, am I talking protocol behaviors and anomaly detection and machine learning and user behavior analytics? And you start throwing out terms, and there's a lot of terms out there. But a couple years ago, Sergio and I wrote a paper titled The 4 Types of Threat Detection, which I used to help educate my ICS 515 class on really the 4 types, the 4 ways you can do detection. And all those other terms that we hear can fall up into those categories. So on the left-hand side, we think about detections based on your environment. It's our knowledge of ourselves lead us to identifying things that are odd or things that are off. So as an example, down the left-hand corner, configuration analysis. So this is where we're looking for changes to the environment. Think of it like baselining, where we see something that's new to the environment. It's kind of a newness detection, new things happening. But it also could be changing of the configuration itself, like modifying a digital relay, or by submitting new code to it, or maybe I'm modifying the GPS clock and I'm changing it in a way. So I'm changing the configuration. The value of configuration-based detection is that no matter what an adversary does, if it's something malicious, we're going to catch it. It's a whitelist style approach, because our environment is in an already good state. To change it to a malicious state, something new does have to be done. And that newness, if you will, is going to pick up on configurations. Now, there's 2 big downsides to configuration detection. Number 1, it detects everything. And so you're talking about a lot of alerts that are going to be coming off these environments. And while we typically look at ICS environments as smaller or static, they're just generally not. They might be more static than an enterprise, but these are highly diverse environments with a lot of changes going on, and you'll get flooded in alerts pretty quickly. The second big downside, which is honestly a downside of the entire environmental category, is that there's no context on what you're looking at from a threat perspective. So it might be, here's a GPS clock modification, or here we see DMP3 packet, and what it's doing is it's uploading a new configuration to the PLC or the RTU that we're using. That's super interesting, and it's good environmental context. There's no threat context there. There's nothing to tell you how it might be being used, why you care as an analyst, or any information that's then going to facilitate an investigation. When we think about modeling as a detection type, that's where we hear a lot about the anomaly detection stuff in ICS security. And a lot of focus has been on anomaly detection. And it's not without value, and we'll talk about that actually in the next slide, but from a modeling category, the promise, as it were, is sort of the opportunity of this type of detection is to take a lot of those configuration alerts and give you less of them. So instead of millions of alerts, maybe we're talking in hundreds of thousands of alerts. You're still getting a ton of alerts, but it's more focused. Now I'm not looking for every single change in my environment, but I'm looking for things that violate a principle of normalcy. What's weird or what's anomalous in my environment. So really the way to think about that is like a baseline plus a threshold plus time. So maybe it's normal to modify the GPS clock twice a month in my environment, but it's abnormal to modify it twice a day or 5 times a day. And so that would generate an alert on that. And And this could be done manually. I can set manual thresholds, but then I might also get value out of things like machine learning to automatically kind of tune into my environment and bake in what normalcy is. The downsides of this is just what I mentioned earlier about the context of the environment. I get some context of the environment, but I don't really understand any context related to the threat because I'm not looking for anything related to the threat. The other downside, especially when we start talking about modeling, is if we are using things like machine learning, we may not even know why the detection alerted. One of the downsides of machine learning is the traceability or the understanding of why that detection fired is not very good. So it's usually based off a mathematical model. We look at it, we go, okay, the system thought it was abnormal, but it kind of has this black box feel. We're going to still, again, talk about some of the values of it, but it can leave an analyst sitting there really not knowing what to do. On the threat side of the house, this is where, again, we're looking for now threat components. The industry has gotten pretty hooked on indicators. And over the years, we've always looked for command and control servers by identifying a specific IP address or domain, or looking for malware by a specific folder path or file path or MD5 hash. And theoretically, the value of indicators is that theoretically they have the maximum context. If I'm looking at something and I say this command and control address was used by this adversary at 2 o'clock on Tuesday at this date, that's a lot of context, a lot of information. Or this MD5 is this malware, and on a system, here's what it does, and it can be used in these ways, and here's what it might accomplish and why an analyst might care. Again, a lot of context. The downside of indicators, though, is they're not very durable and they're not very transposable. So while using an indicator feed for something might be helpful on its own, it's actually not a great way to lead a detection strategy, because you're dealing really with kind of the exhaust fumes of the adversary. You're always picking up on the last elements of technical nature, where in many times the adversary can very, very easily change the technical elements of their attacks. Again, not very durable as a detection type. And over time, then they just lead to a lot more false positives. So the evolution of configuration sort of led to the evolution of modeling in the same way that the evolution of indicators kind of led to threat behaviors, which is, well, I really care about the things the adversary does, and I care about the context around them, but I want to have a more transposable and durable detection type. So threat behaviors are really about tactics and techniques of the adversary. It's the method or the MO of the adversary, the way they accomplish this. So now I'm not so hung up on what are the technical elements. I'm not going to write a detection off of an IP address or a digital hash or a file path, but maybe I write detections on clustering of events that I care about. So say in that Ukraine 2015 scenario, I don't care about the IP address of the VPN. I don't care about the digital hash of the malware. I don't care about the IP address of the adversary's connection to RDA, because those are easily going to change. And the next time we see that attack, probably not going to help us. What I really care about is anytime anybody VPNs into my environment, drops a new file in my HMI outside of a maintenance window, and then RDA is out of my environment to connect back in, that's a SCADA hijack scenario. And here's where it's been used before and how we've seen that potentially be malicious and what you should be thinking about. And now we can have a really durable and transposable detection with lots of context, not bound to those technical indicators. And so that's really what we're talking about today as it relates to MITRE ATT&CK. Next slide, please. So when we think about threat behaviors, again, they help us from a threat detection scenario. And from a threat detection component, like when we're trying to develop the quote unquote perfect detection strategy, leading with threat behaviors is a really good way to achieve scalable detection. You don't have to write a ton of different analytics to actually cover a wide variety of attacks. Again, I'm not looking for a specific adversary now. I'm looking for a whole style of attacks. Maybe I write a detection that looks for any file that writes itself or executes initially in the temp folder that then escalates to move out of the temp folder and then give itself network activity. Man, that's a lot of different remote access Trojans that just fell into that class. Or maybe I write a detection that anytime anybody sends me an email, if that email contains an attachment and the attachment executes a VBA script, and that VBA script reaches out to any IP address and downloads another file, well, that's pretty indicative of a lot of phishing. And so it doesn't take a lot of analytics to get sort of coverage, if you will, but you're constantly thinking and trying to create more threat behaviors. All work together. So how can I use the other detection types? Well, say I've got that SCADA hijack at 2 o'clock on Tuesday. From a detection and amplification perspective, I'm going to want to know what else is happening, because I might have detected one step of the adversary, but maybe there's other steps in that environment. So to be able to say, okay, well, I just detected the SCADA hijack, but show me plus or minus an hour of every configuration change in the environment off of that timestamp of the analytic. Now I can look for the changes in the environment against the baseline, but in context of the time of that analytic or that threat behavior. So now it's more focused. In the same way, maybe I do realize that there's an indicator of the command and control server that the adversary is using. Passing that indicator out to everybody or using it for a wide detection in the future may not be robust, but maybe in the concept of the incident, taking that indicator and scoping around my organization and going, hey, where else have we seen this, can be really useful, because now it's your indicator in your incident and it's very relevant to you. In the same way, anomaly detection or modeling can be super useful from an amplification perspective. Hey, the SCADA hijack took place and there was an anomaly in the process historian. Maybe I see OSI soft PI historian high temperature alarms, and I normally don't see those. And right now I'm seeing them in the same time window right after the SCADA hijack took place. Maybe there's a physical process change now that I need to run down. So I can use modeling to amplify that context that I have in threat detection. But it's got to start with that context, which is, again, why we start and have a lot of discussions around threat behaviors. So inner MITRE attack. Next slide, please. So what MITRE was really effective at is they listened to the community. And they looked at the work that was going on in the intelligence community over the years in the Department of Defense. And they looked at what was happening in the private sector. And they said, man, we really need to get people out of an indicator-based only approach. And we can't just go swing full to the AI, ML kind of discussions. There's still a lot of value in understanding the context of threats. So let's create a framework based only on real-world observations, not theoretical attacks, not research, but truly what have we seen adversaries do before, and let's break those into different tactics and techniques. Tactics being sort of their stage of execution and what they're trying to accomplish, and techniques being the way that they're accomplishing that. Next slide. And so MITRE ended up publishing out this enterprise attack framework. On the enterprise matrix, they detailed from a bunch of different of the vendors and community and government, in other words, contributing all these different reports in APD 29 and 28, and all these different adversaries about what are the tactics and techniques they're using to be successful. And with the hopes of taking this and giving it to defenders and saying, here's your lexicon. As you try to communicate across your teams, as you try to communicate between companies and think about how to detect things, here's the common language we can all use. I want to create detections against bits jobs, or I want to create detections against brute forcing, which is used for credential access, and starting to think about robust detections beyond indicators, which are, again, not very transposable durable, but without the lack of context that machine learning or modeling or anomaly approach is going to accomplish for me. And this ended up really being an exceptionally useful framework. It got all of us talking on the same page, talking about the same thing with documented use cases of what we want to do. Not only useful for threat detection, but response playbooks or red team emulating and so forth. So with the success of the enterprise attack framework, MITRE then took on the challenge of doing an ICS attack framework. And that's really, of course, what we're here to talk about today. And Dragos ended up contributing a lot of our intel reports and a lot of our understanding of the adversaries over to MITRE to help them flesh out that MITRE ICS attack framework. And from our side, Austin was definitely one of the leads of that. So Austin, if you can, take us away, show us the ICS attack framework, get us into that a live demonstration, and let's go from there, please, sir.
Thank you very much, Rob. That was terrific. Now, as Rob mentioned in the previous slide, Attack for Enterprise covered a lot of the enterprise TTPs that the MITRE folks were carefully documenting and enumerating over the years. But as they were going through this process, there were a number of tactics and techniques and procedures that just didn't fit into the enterprise model, and they were very ICS specific. So a couple of years ago, they decided to create a spin-off called Attack for ICS, which really focused on the unique tradecraft used within ICS environments. So Attack for ICS, it shines a light into these unique threat behaviors, and Dragos, we were very happy to be involved in its development. So if you remember from a few slides ago, the Attack for ICS matrix is a little bit different than the Attack for Enterprise. There are some very specific tactics at the top that are specific to the ICS environment here, like inhibit response function and impair process control, and then ultimately impact. In today's presentation, I'm going to be getting into some of these in a specific scenario and diving into some of these tactics and techniques specifically. Now, as Rob mentioned earlier, the tactics are the technical goals that go from left to right across the top, and there are 11 in attack for ICS, and they are a little bit different than attack for enterprise, especially on the right-hand side of the chart. And the techniques run vertically, they stack under each tactic, and they represent the techniques and procedures the adversaries would use to achieve their tactics or their goals. So within attack for ICS, there are 81 unique ICS techniques compared to 266 in attack for enterprise. So it's a smaller data set, but still quite significant. So the logical question people ask is, what's the overlap? Exactly where does attack for enterprise end and where does attack for ICS begin? So if we use the good old Purdue model as a example here, we can see that as we get further down into the OT network, there's a lot more ICS specific devices and more ICS specific tactics and techniques that would be used. So what does that breakdown really look like? Well, based on the numbers that we crunched, there's about a 73 breakdown of IT versus OT techniques. So 73% of the techniques in attack for ICS would only really work or only really applicable in the context of an industrial control system. So this is all well and good, but how do we apply it? How does the average person or average network defender take attack for ICS or attack for enterprise and use that to improve their security posture? So today we're going to go through a 3-step process where we're going to create a scenario, execute a scenario, and then identify the gaps in an effort to look for ways we can improve our protection, detection, and response capabilities when we're faced with ICS targeting adversaries. So step one, create a scenario. So it's not too difficult to create a scenario or a mock scenario in attack for ICS. All you really need to do is you could just highlight a number of the techniques under each of the tactics, and that will kind of create a kill chain for you. So when we were building our scenario, we really were keeping Electrum in mind, but we also wanted to incorporate some of the techniques that some of the other activity groups used as well. So this is kind of like an Electrum, Alanite, love child activity group in this case. And when we're creating a scenario, we have to be careful not to come up with too many interesting concepts or unique tradecraft here to give the adversaries any ideas. So the adversaries in this scenario aren't the greatest of hackers. They're pretty low level, but still we'll use them as an example to step through this scenario. So this scenario is based around the Cyberville Energy Center, and it's a multi-purpose facility that produces more electrical grid. So it provides energy storage, peak demand generation, and black start support. So energy storage systems play several roles within the grid. They help with load following and load smoothing and frequency regulation. And in the event of a serious blackout, the Cyberville Energy Center can also play a startup role. So the large-scale battery storage that the Cyberville Energy Center has can help fire up the generator, help fire up the 44 megawatt combined cycle gas generator to get things up and running without any external power, without having to tap into any other transmission networks or other backup sources. So as it turns out, after a blackout, you can't just start things up again. You need power to make the power. So this battery storage helps you do that in a black start type scenario. So this network consists of 3 primary process areas. We have the 240 kilovolt transmission substation, which is it's a NERC medium, so it's a higher voltage transmission station, and it has a bunch of Schweitzer gear in there, SEL gear. The 10 megawatt with 40 megawatt hour battery storage system, it's a whole bunch of lithium ion battery cells. You can see them, they look kind of like shipping containers on the map there. And each of those has a Schneider M340 PLC in there that is being used to manage those cells. And the 44 megawatt combined cycle generator, that has it's a really large plant, has a number of different processes and PLCs and DCS systems in there. But the one we'll be looking at is a turbine control computer, which actually uses a Rockwell PLC. So the intention of this demo setup is to step through a realistic adversary scenario based on the tactics and techniques documented in Attack for ICS. And after we execute the scenario from the attacker's perspective, we're going to look at it again from the defender's perspective using the Dragos platform and identify ways we can further improve our protection, detection, and response capabilities. So one of the big benefits of leveraging Attack for ICS within your organization is it can help you establish protection in depth, detection in depth, and response in depth. It really helps you to kick the tires in your program and understand what adversaries might be using against your environment and how to shore up your defenses in those areas. So again, high level of the network, there's really three process areas we're going to be looking at: the battery network, the balance of plant, and the substation network. So that brings us to step 2 of our 3-step process, executing the scenario that we built. Now, this can be done any number of ways, and it's very effective, even as a paper or a tabletop exercise, just to step through this as a thought exercise almost. If you understand what your controls are, what your detection capabilities sort of are today, you'll probably be able to understand where your gaps are. But there's nothing like a real scenario, so that's what we're going to be doing. And in our scenario, we created a network in our extensive Dragos lab environment, and we're actually simulating this scenario in that lab, and we'll be executing against that those actual pieces of control equipment. And of course, there's always the option of executing a scenario or doing like a live pen test on an operational system, but you really gotta be careful and know what you're doing, and perhaps maybe do it during an outage or a turnaround. But you really need to be careful when doing work like this on an operating plant environment, because you don't want to create a process upset or put people's lives potentially in danger or anything like that. So I have pre-recorded the video, and it moves kind of fast, but we'll step through it here. So we'll start off with the internet accessible device technique under the initial access tactic. So in this case, the lithium-ion battery system, they're typically sold as kind of a control system as a service. They'll typically sign like a 10 or a 20-year contract with the end customer, where this vendor will provide the batteries. They'll install them, and they will monitor and maintain them for the duration of the contract. But this requires 24/7 remote monitoring and remote access into that network. So in the case of our scenario today, we're going to be looking at something similar to the 2012 Telvent breach, where the vendor was targeted and compromised, and then the adversary was able to leverage the vendor's remote access into a number of different in this case, it would be power plants, but in the 2012 breach, it was pipelines across North America. So they were able to leverage that remote access and gain access into these environments and move around largely undetected, because I mean, they were using the same methods and the same credentials that the remote vendor would normally use in those environments. So it's a pretty stealthy attack, and that's maybe the most sophisticated part about this adversary. And of course, this falls under the initial access, internet accessible device tactic and technique there. So I'll be zooming in and out of these as we move through this scenario to kind of show the context around. So here to the digital cellular modem, and they've reconfigured it to open up a number of ports and allow more services to pass through so they can continue with their attack. The next, network scanning and service scanning to understand what IPs are online and what services are available on those. So they'll be doing some very specific pings and also looking for open ports for things like, because they want to understand what kind of network they have access to. They probably have access to a dozen different networks, so they want to discover what's in this specific one. So once they've done their enumeration and understood what's on the network, they'll start to move on to the next phase, which is leveraging the valid accounts that they stole from the vendor. So they're going to move their payloads around the network and take advantage of these valid accounts. I mean, adversaries will always need to, it's really hard to completely live off the land. You usually need some tools at your disposal, some exploits and things like that. So here, the adversary has been using SNAir payloads and beacons to a remote system, and now they're going to execute a beacon to open up their Cobalt Strike command and control access. But they've also put some other tools up there, like payloads as well. But they seem to be primarily using Cobalt Strike as their beacon. And going along with the lateral movement thing, they're also pivoting through a historian in the battery network and into the balance of plant network through that shared historian. That historian kind of bridges the two networks. And here they're executing machine, and now they have access into the balance of the plant network. So they've pivoted down through the historian and into the turbine control HMI. So next, they're going to do some information gathering. They're going to get as much information about the process environment as they possibly can. And that falls under the collection tactic. So here they're just grabbing some screenshots of the running. Doing this as an attacker, you don't want to boot the operators off of the workstation. So you got to stealthily take screenshots without the operators noticing. You can't just RDP into those machines. So now they're going to be using some unauthorized command messages in the battery network, kill chain attack. They're kind of under the development process of stage 2, where they're understanding what is possible in that network. So here, they're just going with some Modbus fuzzing to see if they can disrupt its running process, to see if they can do a denial of service on that battery, and then prevent it from providing power when it's batteries, one of the cells on the .55 network. And they're configuring it to do a Modbus fuzz and just kind of see what happens. So often we find the adversaries will use these networks, exact same equipment always at their fingertips. So moving down to the next stage, under the impair process control tactic, they're going to modify the control logic of the under impair process here in the attack for ICS matrix. So here they are remote desktoping into the engineering workstation in the balance of plant combined cycle network. They've gained access to the turbine control computer, evil turbine control program into that PLC. They stopped the program, they downloaded it, and now they're going to run that again, run mode. So the operators would definitely notice this. When you stop a turbine, it's very, very noisy, and people notice. So this is something that would have not gone unnoticed, and it probably would have triggered some kind of incident response or us to dig a little bit deeper into the logs or what's happening in that environment, which is exactly what we're going to do next. So we're going to step through that same scenario we just executed, and we're going to look at it from the network defender's perspective using the Dragos platform. So somebody tripped the turbine and no one really knows why. So we've been asked to kind of dig a little deeper into this environment and understand what the heck is going on.
Yeah, and while you pull that up, I'll quickly introduce the Dragos platform for people that don't have context with it. So this is our software. Think about it being deployed on like a network switch, on like a span port off of a network switch. So we're passively pulling off all the network data and then analyzing it not only for asset identification, but also then the threat detection capabilities. And so Austin will walk through all that, but if you're thinking about from where would this be in your stack and kind of how it's deployed, think about having like a network appliance down at a substation or a plant, or in this case in the Cyberville range, and then having your server that you're actually accessing up at like your security operations center or similar.
Perfect. Thank you so much, Rob. Now let's first of all take a look at the map view. I mean, this is our first time looking at this network. So the map view is a great way of understanding what assets are in that environment, what the network flows look like, how things are laid out from a logical or physical perspective. So we can see we've created how many different zones? 1, 2, 3, 4, 5 different zones here. And it actually aligns closely with that logical diagram we had in some of the previous slides and during that attack demo. And within the Dragos platform, we actually have 2 different views of the network. We can use the Explore map, which is more of a free-form way of like slicing and dicing and divvying up the network in real time. And we also have the structured view, which allows us to view it in a more pre-set out format. So here in the structured map, we've laid things out in a very similar format as those logical network diagrams that we had in the previous slide. We have the remote access zone, we've got the battery zone, the historian zone, and the substation zone. And we can kind of see that pivot path between the battery zone into the historian zone. They both kind of share that network bridge. And you can see how the adversary would be able to move through there. And we can even do this replay time bar feature where we can drag the time or replay the attack and sort of see what happened, what the adversary was doing throughout the attack, and see how that network traffic changed during that incident for that very specific time zone. And of course, we can click on these zones to see all the assets in there, or click onto an individual asset like the turbine control PLC, which was really what we were called in here to look at. Something went terribly wrong with this device, so we've been asked to investigate a little bit further and see if there's some sort of cyber incident happening. So when we look at the turbine control computer, we can see a lot of information about it, even the serial number and the firmware version, and the cards that are attached to it, and the IP address, and the protocols, and the amount of traffic for each protocol, and information about some of the cards on that PLC. And then this is the interesting area that we want to look at, is some of the notifications associated with it. So if we scroll over here a little bit, we can see the PLC was restarted. There was a write detection. That PLC program was changed. A forced stop. So there's definitely some interesting activity on this PLC in the last few days, actually. So something's going on here. So this will trigger us to, now that we're familiar with the environment and the layout, we will pivot over to the detection quadrants here. Now, of course, Rob did a terrific job introducing the 4 types of detection. I think that's a great addition to this whole slide deck, to this whole presentation, to dive into that in more detail and provide some justification for why the Dragos platform uses this model, which I really feel helps clean things up quite a bit. I've worked with other systems in the past where all of the detections just kind of fall under one category, and then you're just sifting through 80,000 alerts a day, and it's really difficult to put things in context or slice and dice the data in those models. So we're going to start at the top left corner here, looking at the modeling detections. Now, again, as Rob mentioned earlier in the presentation, modeling detections sort of take a mathematical approach to detecting threats by defining what normal looks like in the network and then looking for deviations in these traffic patterns. This is often called anomaly detection. And in this case, we don't really have any detections here because the adversaries are working within our model. They're not doing anything that the remote support staff don't normally do. They're using the remote desktop. They're pivoting to the network. Support staff would normally do. So we're not getting any hits here. We are seeing one detection, which is it's like a null, also known as a null session. So someone's doing some SMB or Windows C in running environment. The threat behavior quadrant. Now, these are the detections that are the codification of threat tradecraft and represent the TTPs of an adversary, what they would typically use in a network. And we do have some really good hits here. These are the ones that whenever there's a threat behavior detection, you really want to dig into it and understand what's happening there. So we see at the top of the list an IEC 61850 scan. So it looks like the adversary was trying to find relays in our network. They were probing around looking for a specific port that is used on IEC 61850. So that's interesting. And there's also some RDP detections here. So although it's difficult to detect an adversary who's living off of credentials that are normally used, they are doing some interesting things that the remote support vendor wouldn't normally do, like non-standard RDP ports. So they're not using the typical remote desktop port. They're using a lower port, and we're also seeing multiple users. They're logging as multiple users in the same device within a certain amount of time, and also they seem to be pivoting from one source to multiple different devices. And we're also seeing some scanning and port scanning. So those are things that are unusual on a network, unless you're doing that kind of activity regularly, which it wouldn't be a good idea in an industrial control environment, really. So jumping down to the bottom left, configuration-based detections represent deviations from the normal operational state of devices on the network. And here we're seeing the forced PLC stop, a PLC restart and write. And these are things on a plant that's running well, that's up and running, that's been running for some time. You're not going to see a lot of PLC changes. They're not necessarily going to be starting and stopping the PLC on a regular basis. So these are quite unusual to see. So, and this is what probably triggered the operators to bring us in, because the turbine just shut down because someone uploaded a different program to it. And we're also seeing some Modbus exception codes. So this is an artifact of the fuzzing we did earlier with the SMOD tool to send some illegal function codes and illegal packets to the Modbus devices, to those Schneider PLCs that are managing the lithium-ion batteries. So it's good. We are detecting that. We're seeing some of these odd configuration things occurring on the network. And then moving over to the indicator quadrant, we can see these are indicators of compromise, really. They're illegitimate files being transferred on the network. We're seeing Mimikatz getting shifted around the network. Downloaded the Mimikatz file, and also an MSF Venom, which is a Metasploit payload, getting transferred around. So it's not uncommon for adversaries to use a C2 in conjunction with Metasploit and other tools. A lot of the adversaries that we track seem to use a lot of these commodity tools actually in their attacks, because I mean, you don't need to come up with anything novel in a lot of cases. Often using the standard pen test tools is enough to get you into a network and help you move around laterally. And often people aren't looking in their ICS environments, so you'll go undetected anyway, but not in this case. So as an analyst, our ultimate responsibility is to determine if we need to engage the IR team or not. Do we want to hit that big red button and spin up the incident response case? And we got to be careful when we do this. We don't want to cry wolf. We don't want to be hitting the IR button all the time and with every little alert that pops in. We want to be really sure before we spin up that IR response team that something's going on. And we also want to arm that IR response team with the pertinent information that they need to be able to make decisions about triaging devices and doing forensic analysis on devices. We want to make sure that we can help them optimize their time and their focus. And that's something that as an OT SOC manager, like it's something that I struggled with in the past. You know, what we've got this detection, what does it mean? What's the context? Some of these detections, and especially in the OT space, they can be a little daunting. You don't necessarily know what a Rockwell PLC is or what a SIP for stop is, but that's why we have created these playbooks. So in this case, for the forced stop of a PLC detection, if we dive into the playbook, it gives us some of that background context around the alert, why we should care, how it happens, and why it could be something malicious, and also how we can investigate it. So it gives us some tasks here that we can follow to collect that data, to either, if this is the only alert that we've got, we can use this process to help us understand if it's benign or not, or if there's a number of alerts, if we're quite certain there's an intruder, we can use this to help collect the information we need to pass on to the IR team. So in this case, we're quite certain there's an intruder, so we're going to collect the information to arm the IR team with what they need to be successful. So we have some links here between our playbooks and what we call query-focused data sets, which provide a lot more rich context about what's going on in the network. So in a lot of cases, we'll want more than just the alert information. We'll want some forensic kind of evidence, more details around what's going on in the network. And the Dragos platform does collect a lot more information. And a lot of this doesn't end up in detections. A lot of it gets stored in the database in case you need it. And you can navigate through that using these QFDs. So in this case, we want to get some of that forensic information about the SIP protocol, about the Rockwell protocol, understand what was happening, when it was happening, and what devices were involved. So we know that the PLC is 10.10.20.10, so we can filter for that value and just do a filter on that destination IP address and just sort of see who's been communicating with it. It looks like it's the 10.10.20.8. Primarily, that's the engineering workstation, and then another HMI or something here has been communicating with it. But we can sift through this data, filter through it, and find out when this write occurred, what asset did it, and share that information. What else was happening around that incident, around that time, that may not necessarily be an alert, but it may be pertinent information for the IR team to look at. So if we go back to our playbook again, we can see there's another step to collect the SIP identity information, and this will help us identify the specific PLC that was involved. So we know it was that 10.10.20.8 or .10, sorry, and we can get some information about the cards on that device and the serial numbers and stuff. So when the IR team needs to go out and do some forensic analysis on the PLC or pull that PLC out to uncover what program has been downloaded to it, we can ensure they're pulling out the right PLC and have all the information they need there, or the right cards that are impacted by that. So if we follow these steps, we can collect all this information and then add it to a case or create a new case or export the data and pass that to the IR team so they can proceed with the incident response and be armed with the knowledge that they need to be successful here. So if we go back to our detection quadrant again, there were a number of files that were transferred around the network. I've got to change my date range. We know the incident occurred between the March 20th and the March 31st. So that's great. We can really filter down the range and focus in on the date or even the times which we believe the incident occurred, and focus in on the alerts that happened during that period. So here we saw the Mimikatz and MSF Venom payload getting tossed around. So we can take a look at what other files they were transferring around that didn't necessarily trigger on an indicator. They weren't like blacklisted files, but what else were they transferring during that time period? So we can take a look here at the files that were being shuffled around the network. We can see Mimikatz was moved around here, and some beacon files. These beacons didn't get triggered because they obfuscated them. They encrypted those beacons, so they didn't set off our default signatures for Cobalt Strike beacons, but they didn't obfuscate Mimikatz for some reason. And we're also seeing some engineering files they're transferring around here as well. The turbine control HMI, so they're pulling that back, exfiltrating that, and exfiltrating some of the screenshots here. And we can download any of these files that were pulled by the adversary and take a look at what they were either transferring onto the network or what they were exfiltrating out of the network, so I understand what information they're being armed with or what kind of data they're going after, which could be very helpful. And of course, the adversary wants to develop their stage 2. They want to create that process impact. And in order to do that, you've got to really do your homework about the engineering that's taking place in that environment. You've got to work to understand the process. And then as an attacker, you want that process to work against itself. You want to find the weaknesses, not in like the exploits of the software, but exploits in the engineering process itself to do some kind of destructive effect. So we have completed our operator analysis. We have armed the IR team with the information they need to be successful, to triage and restore and recover the environment here. And now we are going to identify the gaps. The next step of the process is to identify the gaps in our detections. So one area we want to look at is that internet accessible device, that cellular modem. It's such a weak point in this whole scenario because we have no real visibility into it at this time. The adversary was able to move in and out of the network without us really knowing about it. So getting more visibility into that device, I think, would be really important. Network service scanning, we hit all those. There was some scanning for specific ports and port scanning, so that was detected. The valid accounts, although they did use valid accounts, they were doing things that looked malicious, like escalating privilege and moving laterally through the network quite a bit, and jumping from one site to one or endpoint to many endpoints using RDP sessions. So there was definitely some detections around those valid accounts. Screen capture, although we didn't see some kind of screen capture detection, we were able to manually go in and identify screen captures and data that was being exfiltrated out of the network. So we could maybe look at shoring that up a little bit more. We did get some alerts around the unauthorized command messages and the modification of control logic with the force stop of the PLC and the Modbus exception code detections and the PLC write detection. So all in all, up a little bit there. Sorry, did you guys? I think my computer froze up for a second there. But there's always ways you can get more protection in depth, detection in depth, and response in depth. So our recommendations after this scenario. Sorry, did you lose me there? How long was I gone for?
Okay, just a couple of moments.
A couple moments. Okay, good. We don't have to redo the whole presentation for a third time. That's good. That's good news. That's good news. Okay, so the recommendations that we'd have in this scenario would be to implement two-factor authentication. Anytime you've got remote access into your environment, you want to make sure you've got two-factor authentication going on. And ideally, you want to have control over that remote access. In this case, where the vendor really is managing that system, it's hard to enforce that. It's hard to have you control that remote access because it's really their battery system. But in many cases, you can set up mechanisms where they only get remote access when you switch it on, when you give them access specifically. So always a good plan when dealing with vendor remote access. And then, of course, moving that cellular gateway off of the open internet would be a good plan. A lot of companies have been moving to these APNs or private cellular networks or semi-private cellular networks that would reduce that exposure quite a bit in case someone was able to compromise that cellular modem. And just to get better visibility into that device, ingesting the syslog of that cellular modem into a SEM and capturing that data there. If it was a Windows-based device or we had Windows event logs, we could ingest that in the Dragos platform. But more centralized event logging would be important around that remote access device. And as far as the screen capture goes, we'd want to, first of all, not allow that pivot through the historian to get the screen capture of the balance of plant. You'd want to not have that historian bridging the two networks. But you'd also want to create a screen capture playbook. And within the Dragos platform, you can create your own playbooks for the operators that you can execute when you run into certain situations. So if you're suspicious of a adversary in your network, one of the playbooks you could run through would be the screen capture playbook, looking for exfiltrated data or engineering data that's being moved around the network that could be used maliciously. So yeah, we found some ways that we can identify and improve our security around this environment. But I'll kick it back to Rob. He's got a few nice concluding slides for us.
Perfect. Thanks, Austin. And yeah, hopefully you all found that educational and informative. We tried not to make it just like, here's a product demo and here's a perfectly crafted alert that perfectly guides the solution immediately and, oh, look, we're done in 30 seconds, because I don't think that's realistic. Obviously, it's our job to provide really comprehensive detections and do all those things. But I think everybody should always be aware that it's going to be a technology and a human answer, right? There's going to be people process technology. So we try to piece together not just the perfect scenario, but where an analyst would have to go and extract out some files and look at some data and how you would piece those things together so you understand the flow. And from the ICS attack side of the house, those were those threat behavior-based detections and looking up at those to understand really the context around the adversary. We took it from here's what's going on from a controller perspective, again, try to be educational, but we'd really want to speed up that process by having those threat behaviors. So from kind of the Dragos perspective and what we do for our customers and similar, and this is just really to talk about a blog that we just recently launched and this process. One of the things that we do pretty uniquely in the industry is for our technology, we have these concepts called knowledge packs. And that's not only new configuration detections and signatures and device characterizations and ICS protocol detectors and so forth for a wide variety of your major vendors and so on. But I would say, yeah, of course, the indicators and so forth, but really the main focus of them and the really unique part are those threat analytics that map back to that MITRE ICS attack framework. That way we are constantly coming up with new detections from our intel team going out there and tracking these adversaries. And then with each one of those, we pair up these playbooks on those step-by-step guidance. So if you can go ahead and click through, Austin. I'll just give quick examples of these. We just saw in the demo, but basically the idea is on each one of these knowledge packs being able to consistently get new information. So next, and here the kind of the promise from us, or kind of the commitment and what I think is a real big value add, is every month we're pushing out these detections. So just like you saw the protocol detection and the QFD or the query focused data sets that we got in the platform, every month our team is coming up with new detections, new characterizations, new content for you all. The next slide. And then, like I said, the big value, the stuff that I get really excited about, the stuff that is really the subject of this webinar, was around those threat behaviors and making sure that you don't have to think about constantly creating every single detection, but it's just something that we consistently do for you, especially with our insight, kind of our global insight in the various activity groups and threats that we track. Next slide. So as an example of like one of those threat behavior ones, if we would have made a shorter scenario we could have triggered the HMI discovery detected as an example. And here you see it maps that threat behavior quadrant, and specifically it shows you the ICS attack tactic that's used, in this case, discovery and lateral movement. We've seen this being used by Xenotime, one of the activity groups or one of the threats we've seen before. And then it tells you a lot of information about what happened. That way you have the right context to go and make sure you chase this down. We could get ahead of the adversary modifying the battery bank or modifying the control system by seeing those behaviors that they're using to actually achieve their effect. But more importantly, for the context of this scenario, we see that this has been seen before as a stage 2 action, and we've seen it as the discovery and lateral movement ICS attack tactic, specifically on the valid accounts or remote system discovery technique. Again, that way we can get a really good in-depth view of how we're thinking about this and what context we have for the detection to then move into those playbooks. So just go ahead and finish out with the last two, and I'll go ahead and wrap up here, Austin. So with each one of those analytics does come those investigation playbooks. Basically, our services team, we have a pretty robust services team that's well known in the industry, but what we really use them for, next slide, is to take all of their insights, and really about 50% of the time that they're spending is spent on new playbooks and insights to push into these knowledge packs. That way our customers benefit from all the experience and all the insights and all the engagements and all the toe-to-toe instant response cases with the adversary we're doing, so that there's this continuous content flow. That way, if somebody has the Dragos platform, what they really also have is the entirety of the Dragos team kind of acting as their content team, constantly capturing their knowledge and moving it down in these monthly knowledge packs. So hopefully you enjoyed the webinar. Hopefully this was educational for you, not only on how to think about ICS attack and really what it is, but also to put it in construct of what an adversary would do in an environment, and kind of what are those tactics beyond just the page you see up on MITRE. What are some examples of what those could look like, and emulating those. And then from a defender perspective, you're going to need not only to get detections, which I think everyone's kind of aware of, but you also do need that environmental context. Is this an HMI I'm looking at? Is it an engineering workstation? Was this a PLC that just got accessed? The game is not really about just generating a detection. If the whole thing was a competition of who could generate detections on things, Snort and any rule would have won years ago, or a baseline based approach. The game, as it were, the point is, can we get the environmental context of what we're looking at? Oh, that's an engineer workstation and a PLC interaction inside of a battery bank. And can we have the right threat context of, oh, that was a lateral movement through a historian over to an engineer workstation, now they're doing a impair process function technique. Can we really understand both the environmental and the threat-based context? And by combining those together in the same way, not separating them out, we can get to a place where we can really speed up investigations. And it's not just about detecting the attack. In this scenario, as an example, Austin talked about how obviously when the turbine control stops, it's going to be noticed. Okay, no kidding. But why did it stop? Root cause analysis is extremely important in this field. So the engineers and the operators wouldn't know why it stopped. And as they're going through their maintenance procedures, or they're going through their own disaster recovery kind of plans, and their own ops plans, they may not consider cyber. And we've seen this happen before. We've seen it happen in the 2016 Ukraine attack. We've seen it happen in the Trisis attack in Saudi Arabia, where if you're not actually doing proper root cause analysis, the operations plans could do more damage than the attack itself. So the investigation team isn't just about detecting the threat, although you should, and you should get ahead of the incident. The real value at the end of the day is making sure that you have the right information at the right time to empower the right actions. And that, again, that's a root cause analysis discussion that's going to go way past generating alerts to send to a SIM, and going to be way more around understanding the environmental and the threat context, and being able to understand the story of what happened, truly understanding the intrusion and what took place. So with that, thank you for your time today. Thank you for staying with us and learning a little bit about ICS attack, as well as how it would look from both offense and defense perspective. And Carol, I'll pass it back to you.
All right, thank you so much, Austin and Robert, for your great presentation, and to Dragos for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.